So next we're going to introduce what's called a span. And like a lot of things, this requires some setup. So we're going to start with a list of vectors. Okay, so we've got vectors vectors v1, v2, all the way up to vk, and they're all vectors in Rn. So remember how to interpret this, right? K is the number of vectors in the list, and n is the number of coordinates. Okay, so once you have this situation, the idea is that basically all you have a list of vectors and they all have the same number of coordinates. That's what we're really talking about here. Well, what happens if you want to take their span? Well, that's what we're defining. So the span, and this is the notation, right? Just write the word span and then list the vectors uh, immediately after inside these curly brackets. So we use curly brackets and then list the vectors separated by commas. Okay, and what it means is it's the set of all, and that's kind of, let me circle the part where it says that. It's the set of all possible linear combinations that you could form. Okay, so you've got this setup here. We've got V1 all the way up to VK. We've got a list of vectors. That's enough to be able to start talking about linear combinations. So what happens if you take all the different linear combinations you could ever possibly form and you put them together into a set? Well, you get the span, and that's what the span means. Okay, so just to tie this together to our two previous examples, here's an example of taking the span of two vectors. In this case, we've got a vector 1, 1 and the vector negative 1, 2. So the span of those two vectors is the set of all possible linear combinations you could form. So this claim here is saying that this vector that has coordinates 4 and 7 happens to be one of those linear combinations. And that's what this symbol means. It means belongs to or is an element of. So the way you would read this line is you say the vector 4, 7 is in the span of the vectors 1, 1 and negative 1, 2. So well, how do you know that's true? Well, that's actually what we checked 2 pages ago, or 1 page ago, right? We checked that this vector is a linear combination of these two vectors. So that's where that's coming from. Okay, so that's justified by that example. And in this example here, here's an example of what it means for something not to be in the span. Okay, so the vector 3, negative 4, 1, that fails to be in the span of these two vectors, 403, 403 and 1, 2, negative 2. And this symbol, you notice it's the same belongs to symbol, but there's a line through it that crosses it out. So that's the notation that means does not belong to or is not an element of. So this is saying that the vector 3, negative 4, 1 does not belong to the span of 403 and 1, 2, negative 2. And just like the other one, this comes from our previous work, right? We checked that here. We showed that in this example, B is not a linear combination of A1 and A2. So because of the conclusion that we had down here, that's how we can make this statement. So there's really, you're talking about the same sort of ideas, just with different language and different notation. And that's one of the things that's helpful in linear algebra. It can sometimes be confusing, but it's nice to be able to have different points of view and come at a problem from several different angles.